Hello everyone, welcome back to the channel, and today we will be starting with another topic, binary search tree from our SD sheet. The first problem we are going to discuss today is check for BST. The very basic question, the first question from this particular topic, what is a BST? And you are given a tree, you have to return true if it is a binary search tree, if not, return false. For that, first understand what is a binary search tree, and that is this question about. Let me just quickly check if we are live. Yes, I think we are. Okay, so have a look at this one. For example, you are given a tree like this, which is 20, 10. Let me just draw some tree first of all. Then I have 7. Okay. Next, what I have is 25, 30, 50, 10, 9. Okay, for example, you have a tree like this. Let's check if it is a binary search tree or not. So the property of binary search tree is that every left child's value should be less than the root's value, and right child value should be greater than its root value. This is the property of binary search tree. And when I talk about left and right child, this should follow for every subtree in this entire tree. What do I mean by that? So see, you have 20 as the root. What is the left child? It is 10. So 10 is less than 20 and 25 is greater than 20. So these two nodes follow this property. But same should apply recursively for every node in this binary tree, where this is another subtree, right? So it should follow a property that 7 is less than 10 and 9 is sorry, I think I made a mistake here. 9 should be greater than, this right node should be greater than 10. And now I'll give you two options. Suppose I give 11 here. So for this subtree, I follow the property that 7 left child is less than the root, right child is greater than the root. You have to also make sure, so far this we got this 20, right? So as I was traversing through the left subtree of 20, did I come across any node value which is greater than 20? Not yet. So till here, this is following the property of BST. Just assume I replace this value with, let's say, 31 here. Okay, so you will say that this subtree follows the property of a binary search tree. Why? Because 7 is less than 10 and 31 is greater than 10. So this is a BST, this particular subtree. But you will observe that 31 cannot exceed the root value, which is 20 here. So this is the reason that I will say this tree is not a binary search tree. Why? Because I have to make sure all this while I was all in all traversing the left subtree of 20, right? And this was one of the subtrees. So I should never get any node which exceeds the value of 20. Same goes for all the subsequent nodes below 10. For example, if I had an extended tree like this, right now let's give it 12 and it follows the property. If I give a value like this, some value less than 7, which is 3, that is okay. And if I give another value which is 13, let's say. So 13 is greater than 7, 13 is less than 20 also, but 13 exceeds this 10, which should not be the case. It will not be a BST anymore. Why? Because I was going through the left subtree of 10 and this 13 turns out to be greater than 10. So this is not going to be the BST. So I hope you have understood what BST is. If I talk about the right subtree, 25 is greater than 10. This is good. 30 is not less than 25, although 30 is greater than 20, which we actually want, but this 30 has to be less than 25. So I can either have it 22, for example, anything which lies between 20 and 25. So I hope you understood the point here, what is a BST and what is not a BST. So the question says you have to given a tree. For example, let me take this this is a very small example, 2 1 3. You are given a tree like this, 2 1 3, and other tree, let me draw another tree which you were given in the test case. I don't know why they've given such simple and not very good test cases. 2, 7, 6, skewed binary tree, this is 5, 9, 2, 6. So as we go towards the right child of these tree, I want to get a value which is greater than 2 every time. I got 7, but 6 is not greater than 7. Here itself it does not follow the property of a BST. Talking about this particular tree, it follows the property of a BST because this value is less than 2, it is greater than 2. How are we going to solve this question in code? Let me just find out a better one, last example, which is probably on which I can show you a good dry run. Although this is not too good, the one I took was better one. But let's take one more example. For example, I have 4, 2, 5, 1, 3. So now you understood one thing, that I have to check this condition for every subtree, and for every subtree I need to have some track of what is the maximum value it can go or what is the minimum value it can go. Let's understand it in this way. For example, I started off with root value. Okay, let's say this is my BST function. Okay, right now it's taking a node root. Let me not write complete data type. For example, it has root that I'm giving into it, and it has its range, min range and max range. That tells me for every node while I am checking, I should have a track of what is the, in order for it to follow the property of BST, what is the maximum or the minimum value, or what is the range in which that value should lie, and how are we going to decide it? Let's understand. Right now I have 4. For example, this is the root value. I just have to check if it lies within the range, and what will be my range, min and max. How am I going to choose that? You will understand, don't worry, but just give me a second. So then subsequently I will just check for root, then I'll go to the left part, and then I'll go to the right part. So this is going to be pre-order traversal. But before that, what will be your base case condition? If your root is null, tell me one thing, what are you going to return in this case? True or false? So you do not have any node to evaluate, so obviously you return true in this case. Now I will check what is the case when I should be returning false. So what is the case in which I might return false? So the case that I want to check is if this root value, let's assume for now I have one range, and how this range is going to be determined I will show you in dry run. But for now let's assume that I am currently at this node. I will simply check if my root dot data, okay, first of all I'll check if my root dot data is less than minimum, means it does not lie within the range, less than min, or this root dot data is greater than or equal to max, means if it exceeds my range I return false. Now I have handled the case in which I should return false. Now when should I return true? So basically if it does not hit this condition, then my target would be to check the similar thing for the right subtree, for the left subtree and the right subtree simultaneously. If one of them gives me false, I should get my function should return me false. So the next thing I'll check is that you return BST, you make a call to this function for left part, and you now your min and max, how will your range change when you are making a call to the left subtree? You have to make sure that any node in the left part, okay, should not exceed my root value, whatever root I am at. So right now I was at 4. I have to make sure when I'm going at the left subtree, I'm making a call to this node, okay, so this node should not exceed 4. So the maximum range, minimum will remain as it is, but maximum will be determined by root dot data. You understanding what I'm trying to say here? As I'm moving to the left subtree, so the first node that I'm encountering is this 2. So what is the maximum value at which this node can go? I just came from 4. I want to make sure that it does not exceed this value because I'm at the left subtree, and left subtree should be less than the root's value. Okay, and means not simultaneously, I am doing an AND with BST, making a call to the function by passing root dot right. So don't get confused, root dot right. And see, when I'm making a call to the root dot right, okay, I have to make sure that it does not go less than the root value. So in this case, your minimum will be your root dot data, and maximum will be as it is, whatever was there previously. Now let's do one dry run and you will understand how these calls are being made and how the minimum and maximum are getting changed. Let's see. Wait. So I start with BST. This is, let's say, my call stack. I start with BST. I'm writing F4 here. Okay. Then I go to the left subtree. I make sure that right now the initially min I'm passing is integer.min value and maximum is integer.max value. So in integer, you know what it is going to be. For representation purpose, I'm doing minus infinity to infinity. Okay. When I go to the left subtree, okay, so this condition does not hold true because this lies within the range. Now I go to the left subtree, which is f of 2. So when I go to the left subtree, I make sure that my minimum value is minus infinity, but my maximum changes to 4. Okay, and my root currently is 2. Okay, so I check root dot data, which is 2, is less than or equal to min, means if it does not lie in the range, but 2 lies within this range. What is the range right now? Minus infinity to 4. So it lies in this range. So I'm not going to return true as of now. You are seeing this case. If it lies in the range, I just go to the next line and make a call to the left subtree. Now I go to the further left of this tree and my minimum remains same, but my maximum is now root dot data. So my minimum is minus infinity and this time my maximum, the range maximum is 2 because I was at 2 and I'm going to 2's left, which is f of 1. So when I'm making a call to f of 1, means this BST of 1, what is my range? Minus infinity to 2. So I can see that 1 lies within this range. Yes, it does lie in this range. So I again go ahead and make call to BST. But now this time the root is null. So I return true. So this true will be returned to f of 1. So basically I have gotten true for this returns true to 2. So the next thing is I go and execute the next line, the next part of code, which is making a call to the right subtree of 2. And in this case, you will see I am modifying my minimum value with root dot data. So what was my root? It is 2. So right now my min is 2 and my max is what? What was the max when I made a call to it? I think it was infinity or 4. I think it was 4. Yes. It will see 2 made call to left, that is when my range was modified to minus infinity to 2. Okay, and now I am again making a call to the right subtree of 2. So what it will be, root dot data will be my minimum, which is 2, and maximum will be what was going initially. So I think initially maximum that was going was 4. So now the range will be from 2 to 4, and I can see that when I make a call to f of 3, my f of 3 follows this range and this also returns true. So basically now this function returns and of both the answers, which is true. So 4 has gotten true from this left subtree, and I go ahead and this will be removed from the call stack. Okay, now f of 4 will make a call to its right subtree, which is f of 5, and this is making call to BST for the right subtree. What is going to be your minimum value? Your minimum value is going to be the root dot data, which is 4, and maximum is going to be infinity because initially it was infinity, and that will continue. Okay, so you have to take care that this thing you have to determine. This is all about recursion. I don't think I need to stress more on this fact that how recursion calls are being made and how we are tracking this min and max value. For this you will have to have a good grip over recursion and the call stacks that we are making call to. Okay, then last call is to f of 5. Again, if I see that f of 5 is lying in the range of 4 to infinity, so this value goes and makes a call to the null value for its left, and for its right also null value. It returns true. So this function also gets removed from the call stack and it returns true for itself to f of 4. When f of 4 gets its answer from both left and right child, it will be removed from the call stack, and finally it returns bitwise and of both the values, which is going to be true. So this tree will finally return me true, and that is all about this question. Although this was the basic one, but it was the foundation of BST, so you need to understand what we are doing here. Now I'll move to the code and code it for you. It is exactly what I have written here. It's not even the pseudocode, it is the exact code. So let's check. I'll see if you guys have any doubts meanwhile. Okay, So let us start with the code. We'll take another function, as I told you that we are going to keep track of two other things here, which is your range, min and max. So boolean, make a call to this function BST node root int min, let's say int max. Okay, if root is null, root is equal to null, return true. Then you are making your decision for the root value. If your root dot data does not lie in the range, that means it is less than or equal to minimum, or your root dot data is greater than or equal to maximum, then you are returning false. And in the other case, you just check for the left subtree, update the min, check for the right subtree, update the min max, whatever it is, and then return BST root dot left. So when you're making a call to root dot left, your min will be as it is, your max will be updated with root dot data, that it should not exceed this value. And with BST, we're making a call for the right subtree, your min will be root dot data and your max will be max. Okay, that is it about. And then from here, let's return BST by making call to root. Min will be integer dot min value and max will be integer dot max value. Cool. Let's see. So the return type, you can see that it's not true or false because that compiler is taking care. If you're returning true, it returns 1. If the answer is false, then it is returning 0 in your answer. Okay, so that is all about this question. I hope you understood it. So try this one, and then tomorrow we'll take other question of BST. So that was all for today, everyone. Thank you and take care. See you all in the next lecture. Bye bye, everyone.